If someday, you suddenly wake up from a dream and find the sun is gone, Earth plunged into eternal darkness, who do you think did it? A black hole? Actually, no. If the last star in the Milky Way goes out, the entire universe has no light. Who do you think the culprit is? What's scarier is, this culprit is right beside you now. It's making your body age, cities decay, and stars die. It's even slowly killing the whole universe. But you've never seen it. It has no shape, no color, no sound. Even in the dozen minutes you watch this video, it keeps getting stronger. Scientists say, from the first second of the universe, it has never lost. It has swallowed stars, swallowed galaxies. In the future, it will even swallow time itself. And a black hole is just a small worker before it. Today, let's talk about the real ultimate killer of the universe, entropy. Entropy. Don't be scared by the name. Entropy increase isn't complicated. Let me ask you a question. Isn't your room often like this? Just cleaned and tidy. After a few days, the desk is full of parcels. Clothes on the chair, bedside table cluttered with stuff. The amazing thing is, the room gets messy without effort, but to make it neat again, it takes half a day. Why? Because the universe naturally loves disorder. And this trend from order to disorder is called entropy increase. Simply put, entropy is a system's level of disorder. Neater, lower entropy, messier, higher entropy. And entropy increase is the process of rising disorder. It sounds like just a messy room, but in fact, the whole universe follows this rule. In 1848, German physicist Clausius was studying steam engines. He found something strange. No matter how perfect the machine, some energy is always wasted. This energy doesn't disappear, but becomes waste heat spreading around. Later, Clausius created a brand new concept, entropy. In Chinese, it's translated as Shang, entropy. A few years later, he proposed a statement that later shook the scientific world. The total entropy of the universe never decreases, it only increases. No one realized at the time that this short sentence, the fate of the universe, was already written. Later, the British physicist Kelvin continued the deduction. He reached a chilling conclusion. If entropy increases forever, the universe will eventually lose all usable energy. It will fall into utter silence, which became the famous heat-death theory. To understand entropy, let's look at a few examples. You have a cup of hot coffee. After a few hours on the table, it will definitely cool down. But have you ever seen cold coffee heat up by itself? No. Heat always flows from hot to cold, until it evens out. Another example, drop a bit of ink into water. The ink spreads quickly. Soon the whole cup turns light blue. But you'll never see the ink gather back into one drop. Because the spread state is more numerous, random, and disordered, with higher entropy. In a sense, the entire universe does the same thing. Energy constantly spreads, order constantly breaks down, and chaos keeps increasing. But here's the question. If the universe loves chaos so much, why do stars exist? Why do galaxies exist? Why does life exist? These things seem to become more ordered. In fact, life and stars only locally lower entropy. But the total entropy of the universe still increases. Think of the universe as a rushing river. Life is like temporary eddies in the river. Eddies seem to go upstream, but eventually the river sweeps them away. Black holes are the most terrifying waterfalls in this river. In 1915, Einstein proposed general relativity. A year later, German physicist Schwarzschild discovered that if a star is massive enough, it will collapse after death, eventually forming a black hole from which light can't escape. At first, scientists thought black holes were just devouring machines. Like cosmic trash cans, anything that enters vanishes forever. But in the 1970s, Hawking changed everything. Hawking found black holes have temperature, and even slowly evaporate. This discovery shocked the physics world. Because according to thermodynamics, anything with temperature must have entropy. And the calculations got even stranger. Scientists found Black holes are among the highest entropy objects. If the sun were compressed into a black hole, its entropy would skyrocket trillions-fold. Why? Because black holes erase all details. A star has nuclear fusion, temperature differences, magnetic activity, and complex structures. The information is extremely rich, but after becoming a black hole, all that info seems compressed. Only mass, charge, and spin remain. Complex order is compressed into minimal info. So, Sheng Bao Cheng, you can think of it this way. If the universe is a library, then a black hole is a super shredder. It doesn't read those books, nor does it understand the content. It only shreds, turning complexity into simplicity, order into chaos, information into silence. So, in a sense, black holes are not the enemy of entropy increase, but the most faithful executor of entropy increase. But the truly terrifying thing is yet to come, because black holes are not the end. Entropy increases. 5 billion years from now, the sun will exhaust its fuel. It will expand into a red giant. Earth will likely be engulfed. Even if it survives, it becomes a charred, lifeless rock. Further ahead, the Milky Way and Andromeda collide and merge. Stars keep aging. New stars become harder to form. The universe's lights go out one by one. Trillions of years later, the last stars die. The universe enters a true dark age. No sun, no Milky Way, no light, no warmth. Only endless cold. But this is not the end. Time marches on. 10, 20 years, 10, 50 years, 10, 80 years. Compared to these numbers, all of human history is less than an instant. Finally, after about 10, 100 years, even black holes begin to disappear. Hawking radiation slowly carries away their mass. Black holes get smaller, weaker, and eventually evaporate. The moment the last black hole vanishes, the universe loses its last massive object. Only sparse photons, electrons, and neutrinos remain. They are millions or billions of light years apart. Temperature approaches absolute zero. No stars, no black holes, no life. There's not even a story. Because the essence of a story is change, and at this point, the universe. Nothing will ever happen again, which scientists call heat death. But the story isn't over yet. Because what happens after heat death? Scientists still have no answer. Some think nothing will happen. The universe will remain in heat death forever. Like a movie paused, lasting for an infinite time. Others think, over infinite eons. Quantum fluctuations may create miracles again. Tiny fluctuations in vacuum might suddenly birth new energy, space, and time. Even a new universe. British physicist Penrose proposed an even crazier idea. He thinks the universe's end may be its next beginning. When the universe expands to its limit, all matter vanishes. Scale itself loses meaning. An infinitely large universe may mathematically become an infinitely small point. Then a new Big Bang happens again. New stars are born. New life appears. New civilizations again look up at the stars. If this theory is true, then the universe never began, and never ends. It just cycles again and again, repeating its own story. Of course, all this is still speculation. No one knows the answer, but one thing we can be almost sure of. Since the universe was born 13.8 billion years ago, entropy has never stopped increasing. It drives stars to burn, drives black holes to grow, drives the evolution of the universe. Eventually, it will drive the entire universe to its end. It's like an invisible river, carrying away stars, carrying away galaxies, carrying away civilizations, even carrying away time itself. And each of us is just a wave in this river. Appear briefly, shine briefly, then return to the universe. So back to the original question. What is the most terrifying thing in the universe? Is it a black hole? No. Black holes will eventually evaporate. Stars will eventually go out. Even time itself may lose meaning. But entropy increase started from the first second of the universe. Until the last moment of the universe, it has never lost. And what's truly shocking, maybe isn't entropy increase, nor heat death. but in a universe destined for chaos. Life somehow emerged, and civilization arose. Humans emerged able to ponder the universe's fate. The starlight you see now. Many have traveled tens to hundreds of millennia. Some have traveled even millions of years. Yet you, in just over 10 minutes, you ponder the universe's fate eons from now. This may be the universe's most wondrous miracle.